Hey everybody, this is our video on balancing equations. By the end of this lesson, you should be able to exemplify the law of conservation of mass by balancing chemical equations. Before we can learn to balance, we need to understand what a chemical equation shows us. So a chemical equation is defined as a change where substances that you start with are converted into something different that have different properties. The substances that you start with, the ones that go through the change, on the left side are called the reactants. And then the ones that are produced or formed, which the word produced there, which are on the right side are your products. You will actually write these in a chemical equation, which we'll talk about in a second, separated by an arrow. And then during a chemical change, the reactants will change into products, and the products will be extremely different from what they started at. They'll have different chemical bonds, different properties, all kinds of stuff. And when you write these down, we write them in what's called a chemical equation or a chemical reaction. And this describes the reaction as chemical formulas. So we'll see them written out with their chemical formula. If you have more than one reactant or more than one product, you will separate them with plus signs, and then you separate each side, reactant and product, with an arrow. So here's an example here, H2 plus O2. Those are our two reactants separated by a plus sign. Yields or produces water. And this one just shows you what a chemical reaction looks like on a microscopic scale. So now let's talk about the law of conservation of mass with regard to chemical reactions. So when you have a reaction take place, the mass of the products must equal to the mass of the reactants. So we can't just come up with new mass or eliminate mass that we started with. And this is all based on the law of conservation of mass, which states that matter is neither created nor destroyed. It just transforms into something else. And in order to show this, you have to balance a chemical equation, which means you have to get both sides to equal out. When you do that, the number of atoms of every element on the reactant side has to equal the number of atoms of every element on the product side. So if you have two hydrogens on the left, you better have two hydrogens on the right. When you don't have, a balanced equation from the get-go and you have to balance it, you do that by changing coefficients. So coefficients are the large whole numbers that go out front of a chemical formula. This value will be a multiplier of every element within that compound. So it goes on each one. And we only multiply. We do not add, subtract, or divide. So let's just look here. I'm going to underline this so you can see it. So let's just look at this 2 here in front of the H2O. This 2 is a coefficient, okay? And with this coefficient, it goes on each one of these elements. So that means that we would actually have 2 times 2, so we'd have 4 hydrogens, and we'd have 2 oxygens. So that's how coefficient works here. And then this just shows a balancing act between compounds and elements. So now that we know we have to follow the law of conservation of mass, let's look at how you do that. So you have some steps to follow when you're balancing a chemical equation, and it's really not that hard. So you would write the chemical equation using the reaction formula and the symbols. So the plus signs, the equal sign, the chemical formulas, all that good stuff. You're going to check the number and kinds of atoms on each side of the equation to see if they're balanced. So you're going to see if you have the same number on both sides from the get-go, and then you don't have to do anything. But if you don't, you have to go through and add coefficients in. So if the number of atoms are not balanced, use coefficients to balance the chemical reaction. And I usually do this by setting up what I call a T-table, which you'll see in the GIF that's going to pop up in a second, because it's just easier to lay it out and to see how things are balanced. So here's an example. We've got P4O10 plus H2O yields H3PO4. So what you would do is you would have before and after, or reactants and products, which is what I normally write. And then you write down every element that is present on both sides. So we've got phosphorus, oxygen and we've got hydrogen. So before you write down the numbers on the reactant side. So you see this 4 here, you've got 4 phosphorus. You have 10 plus 1 right now would be 11 oxygen starting off. And then hydrogen, you've got 2. My rule of thumb, when you're balancing, and this will make sense in a second, is you start with the most complex compound first. Okay, always start with the hardest one first. So then we've got, for the after, we've got 3 hydrogens, 1 phosphorus, and 4 oxygens. So I would say start with the biggest compound, which would be the P4O10. That's the biggest one. Well, we've got 4 on the left. We only have 1 over here on the right. So to fix that, we are going to add in this 4 on the H3PO4. So as you can tell, that gives me now, and I know it's going to erase in a second, but it'll come back. That 4 goes on each one. So we're going to now have 12 hydrogens, 4 phosphorus, and 16 oxygen, which are these numbers that pop up here. So now that we've got that, our phosphorus are balanced, but now our oxygens are off. So now we've got 14 here. We've got 10 over here on the P4O10. We don't want to change that one because the phosphorus is balanced. So the next thing we can do is change our oxygens on the water. So when we do that, we need 6 because we had 10, we had 10 over here. So we need 6 altogether. So you're going to put a 6 here. That 6 is again going to go on each element. So now you're going to have 12 hydrogens, 16 oxygens, and that's good because it also balances out your hydrogens. So just kind of watch this for a second if you need to. You can write down these arrows and do all that stuff if you want. I know this